Okay, gang, welcome to the third and final part to this unit on GPS systems. This unit is going to focus more in on the corrections. In the previous session, we learned about the errors that GPS can accumulate and how that equates into accuracies. So, if you remember from that, accuracy, just a GPS by itself, the most accurate it could probably be is about 10 meters or 30 feet. So what we're going to look at here is how can we make that signal a little bit more accurate? And we can do that through a series of corrections. And a lot of them kind of get lumped into what we call differential correction. It's also known as DGPS, differential GPS. And basically what that's telling us is that we're getting a second signal. That GPS is going to pick up a second signal. It's capable of picking that up. And that signal is a correction. And it's going to say, uh, you're getting a signal from this satellite. Well, you need to correct that signal by this distance and this amount of distance at this amount of location. So the way most of these work is that we have a GPS receiver that's on the ground in a known, very fixed, very precise location. That's what we call a base station. So we have that located, and it's in a fixed location. And what it does is that base station says, well, I know my exact location. Now, I'm picking up a satellite signal, and it says this is what it says my location is, but I know my precise location is this, so I'm going to send out a correction. So it transmits that error correction out in real time, and it can do that through two common ways. The first one is just through kind of a ground-based radio station. So there's base stations located around parts of the U.S. where it's like a normal radio station. It's just broadcasting out a signal over a radio frequency, and our GPS picks that up. The other one, and probably the more common one we see, is where that error correction is being beamed up to a geostationary satellite. So geostationary is where that satellite, as the Earth rotates, that satellite stays in the same position right above us. So as we rotate around, that satellite is going to be, in essence, in the same location going around us. Your satellite TVs, your satellite radios use the same thing, where that satellite is constantly in the same location right above us. So that geostationary satellite is going to pick up that signal from the base station, and it turns around and beams it right back down to the Earth, where our GPS receivers then pick it up. So here's a nice little kind of a graphical representation I made to show this. So we have my four satellites up in the sky. They're beaming down a signal, which is being picked up by my tractor, the GPS on my tractor, as well as being picked up by that base station over there on the left. So the base station is picking up that and saying, well, I know my exact location, and from the signal from these four satellites, this is how it's going to be corrected. So it's beaming up that corrected signal to that lower orbiting geostationary satellite, which then beams it down to my tractor and picks it up. And my GPS satellite on my tractor is now going to interpret that. It's going to make those corrections and apply that to my positioning from the four satellites up above. So this is going to give us a more precise location. And once again, it takes us from that 10-meter accuracy down to something, depending on the signal, depending on the types, typically down within less than a foot now, easily. So a lot of GPS systems. So I kind of showed you that image earlier of the DOPS. Here's where you could see too, in a typical GPS system, am I picking up a differential signal? Most GPS receivers that are bought today, in fact, as far as I know, all of them that are bought today have the capabilities of picking up the differential signal. Even the $100 Garmin recreational ones that you see a lot of times that you can buy online or pick up at a local sporting store have those capabilities as well. So right here on the screen is I can find out, do I have differential and is it turned on? And as it says there, yes, my differential is turned on. So that is one of the more common ways that we see. So where can that source come from? Well, as I said, most GPS receivers these days are DGPS capable. There's several differential systems out there. Some of them are free, which is great, and then also some will come with a fee. And typically the fee is going to relate to how accurate it can make your GPS receiver. One of the more common ones, and this is why I have it in green because it's free, it's what's called the Wide Area Augmentation System, or WAAS for short. WAAS actually uses geostationary satellites up above. Another one, and this one, reason why I have it in red is what's called the Nationwide Differential GPS, or NDGPS. It's in red because this system is actually being phased out. Reason being is that this is radio-based stations, so it's just beaming the signal out over radio waves. Another system that we see out there, company OmniStar, now owned by Trimble. Basically, theirs is a fee-based service using geostationary satellites. And another one similar to the NDGPS is what's called IGNOS, and it's a European-based system. And I call it worldwide-ish because it also you have capabilities of picking up in one station in South America. There's one in Canada, Northern Africa as well. So NDGPS, this was, as I said, this is radio stations. So radio stations beaming out a signal, and this was as of May of 2013. Here's what the typical coverage map in the U.S. looked like if you were picking up NDGPS. Here in Iowa, we had some fairly good coverage areas. The whole state was covered either by a single source or multiple sources. One of those, if you got out into Ohio, upper Northwest, yeah, you had a chance where you couldn't pick a signal up. So that was in May of 2013. If you look back to this past August, as I said, this system is being phased out. What you see left is basically around all the coastal areas, out west along the eastern seaboard, up in the Great Lakes, along the Gulf of Mexico. It is this system was created and run by the U.S. Coast Guard. So if you went back and looked at the previous ones, a lot of it was based around large bodies of water. Now it is strictly just around large bodies of water, and really focused in on that. And this is probably where the future of that one's going to be at. It's not going to go away. But something for us on the precision agriculture side, we're not going to see a lot of it here. As for WAAS, as I said, WAAS uses that geostationary satellite. There's actually 3 satellites sitting up above. The blue dots that you see down below, that's kind of where their geostationary reference point is. So they're kind of located closer towards the equator, but you can kind of see the coverage area that they cover. So all of the U.S. into Alaska, pretty much all of Canada, Central America, good chance that that we have WAAS coverage there. Here's IGNOS. Like I said, it's similar to our NDGPS. Here's all their ground stations, so it's primarily a lot through Europe. But then you can see over there on the left where a little bit of North Africa, as well as I mentioned, Montreal, Canada, and then in South America with one station there. They are going also to a satellite-based station, or geostationary-based system similar to WAAS. Here's what that coverage area is looking like as well, and you can kind of see that's where those satellites are sitting at. So, in terms of accuracy, as I mentioned, there was OmniStar. So this was actually put up by AgLear many years ago. They just kind of put it into reference of what these systems are, what their differences were, and I kind of added the fee in there. So what we see here is over on the left-hand side is the typical WAAS, IGNOS, free. Doesn't cost us anything to get that signal. And here we talk about pass-to-pass accuracies. Earlier we talked about GPS accuracy. Pass-to-pass accuracy is, as we can see here, is okay when I get to the edge of the field and I turn around, how close can I be back to how close am I going to be ideally to where I need to be? So a WAAS or IGNOS system is typically 6 to 8 inch pass-to-pass accuracy, which is if I turn around, my next pass is going to be 6 to 8 inches off from where it should be, or what we want to be ideal. Now, as I said, OmniStar, owned by Trimble now, OmniStar has a couple different signals. They have what's called their XP signal. And the price right now, it's cost $800 a year for a subscription. Now, you don't have to pay $800 if you only use it for 2 months of the year. They actually will prorate it out for you. But they have what's called, for the OmniStar XP, that's 3 to 5 inch accuracy. OmniStar also has a little bit better signal, what's called their HP signal, and that will cost $1,000, $1,500, or $1,500 a year, and your pass-to-pass accuracy is 2 to 4 inches. Then we're starting to start getting into what's called the ultimate, or this is the best thing, what we see in terms of GPS accuracy is what's called RTK. We'll get into that here in a little bit, but we could see that pass-to-pass accuracy of RTK, 1 inch, and now even these days it's what we would call sub-inch, less than an inch. So RTK is the best signal that we can get out there. So RTK, fancy acronym that stands for what? Stands for real-time kinematics. And RTK kind of uses the same principles as that where we have a base station. And that base station knows its exact location and it's beaming out a correction. And that accuracy is less than 1 inch. So we call it sub-inch accuracy, which means I'm going to come back and I'm going to be less than an inch away from where I need to be. So the base stations, that's where we see the difference. And there's some different types. Probably one of the first ones that we saw was a local base station. This is where the farmer would buy the base station, would set it up. Farmer owned. The problem is this is going to be very expensive because base stations are not cheap. So this is kind of where it got started from. We're also limited by the strength of that signal. That signal can't travel very far. Well, then we start getting into what's called RTK networks, and this is where we saw John Deere. You see some other ones out there, and basically it's like a cell phone where we're going to stick up a tower, we're going to stick up an RTK base station, and we're going to start linking them all together. So John Deere dealers are known for doing something like this. We've seen some other ones out there, like a DigiFarm is one. You'll see an example coming up. The nice thing about these, it's not as expensive because you don't have to buy that base station, but you're going to have to buy a subscription to a nearby base station. And another one, and this one's probably the cheaper one, is what we call CORS networks. CORS stands for Continuously Operated Reference Station. A lot of government entities got out there, and what their prime example here in Iowa is the DOT, our Department of Transportation, has a CORS network. And so it is a series of base stations all across the state. They're broadcasting their signal through cellular internet. So pick up a cellular internet, you got a cellular package, you can pick it up that way. So this is probably the cheaper of the three different options. So basic RTK, if you have a base station, here's prime examples of John Deere's original Starfire RTK base station. So what you would need to do, take this base station out, set it up on a tripod, plug it into battery, get the power source, and then you'd have to let it sit there probably for at least 24 hours so we can get its fixed location put in. And so, as we can see by the reference here, it's the same thing that we see with WASP. So 3 satellites up above, all beaming their signal down, being picked up not only the base station, but also by the tractor. And the base station picks it up, says, yep, here's the correction, sends the correction out through the radio wave to the tractor. So that is basic RTK. Now, one thing with RTK is that signal will degrade over distances. And so through a bunch of research, what we've found out is that signal will degrade 0.06336 inches for every mile. So if your base station is 2 miles away, take 2 miles times that factor. The other thing that we know is that RTK, the most accurate it is going to be is 0.39 inches. So what we can do to figure out, how accurate can my RTK be, depending on the distance to the base station, we just do a formula. We're going to take that factor of 0.06336. We're going to take that times the distance we're away from that base station. That's going to tell us how much it's going to degrade over that distance. And then, like we said, the most accurate it's going to be is 0.39. So we're going to add that 0.39 on. So the example is I'm 20 miles away from my RTK station. What's the most accurate my system is going to be? So do the math, 0.06336 times 20. Add on that 0.39 to the end of that. And I'm going to find out that the most accurate my system is going to be is 1.65 inches. So if my base station is 20 miles away, I cannot get that sub-inch accuracy because, as we can see by here, it is 1.65 inches. That's the best it's going to be. Now, as I mentioned earlier, John Deere actually has RTK networks. A lot of the dealers have created their own network, and that was where they reached out to a customer and said, hey, Customer Joe, You have this nice grain leg set up. That grain leg sits up high up in the air. We love to put a base station tower on there and broadcast that signal out, and those within range can pick it up and utilize that signal. Um, what we started seeing years ago was that dealers started competing against other dealers in terms of pricing, to the point where finally the John Deere corporate folks stepped in and said, okay, if you're going to do this, this is what the set price is going to be. So it's a fixed price now. So you can go to one dealer and try and get a better price than the other John Deere dealer. It all utilizes the same pricing. This was from a couple years ago, and this is the best, the most up-to-date one that I can find, but you can kind of see what type of RTK coverages that we have across the U.S. Here in Iowa, we have a really good coverage area, and that has probably changed as we've seen some changes in dealerships in the state over the last couple of years. So this is one example of a network system. Another one that's out there is what's called DigiFarm, and they've done the same thing where they've set up base stations all across parts of the U.S. as you can see here. And as long as you're within range, you can pick up that signal and process it through your GPS, utilizing a special set of hardware that they have and they sell, and you're off and running. And you can get those those really good accuracy options. Now this is the CORS network. This is those continuously operating reference stations. And what we see here is this is the Iowa DOT. So every blue dot on here represents one of the DOT locations where they have a, basically it's a GPS receiver that's picking up and knows its fixed location. And what it does is it broadcasts their corrections out through the internet. So if you're in your tractor and you have a mobile phone, or a mobile data plan, take your mobile data plan, you hook it up into the internet on that side, and then that device actually plugs into your GPS system. So in essence, you're getting your corrections through the internet. So it's picking up the GPS, locating that to where you're at, what's the nearest reference stations, and picking up those signals and processing it. So this one actually involves a little bit of that cloud computing, utilizing the internet out there. So the blue dots these are Iowa DOT stations. If you notice, there's some red ones down there in the northern part of Missouri, some red ones in the southern part of Minnesota. A lot of state DOT systems have a system. And so if you're in northern Iowa, you can not only use the Iowa ones, but you can also pick up the Minnesota one. The best part about this is that you do have to register an account for the DOT. The best part is it doesn't cost you anything. It is free. So the subscription is free. You just have to have the equipment to pick up that signal. So out of the having your own base station or joining a local network like the John Deere dealers or the DigiFarm or the CORS network here, the CORS is probably the cheapest because it's not so much buying into hardware or paying for a subscription necessarily. So that is RTK. We've seen a lot of it, and as with most other technologies, the cost of this has become more affordable. We're seeing more and more people utilizing these really precise RTK systems. Great thing to have. Now, everything that we talked about GPS-wise has been based around the U.S. system, and there is other systems across the globe that are possible to use. So once again, GPS, it's global. We're surrounding the whole Earth. There's other systems out there as well. Another one that came online a few years ago was GLONASS. GLONASS is actually run by the Russians. Same thing as our own GPS system. The GLONASS one is a little bit newer. They actually have some better accuracies, and you can actually pay a subscription for that. Some of the more modern agriculturally based GPS systems also pick up the GLONASS signal as well. So which it kind of gives us a little bit better, kind of does a little bit better on the calculation side. Galileo, and the reason why that's in yellow, because this is not fully operational yet. This is being put together by the European Union. Originally started out as with a really aggressive plan. It was supposed to be active almost 10 years ago, and here we are 10 years later, and it's still not fully operational. It's been set back by delays, and there's been some funding issues. I think the last I heard, they're kind of hoping for 2019 or 2020 to do some initial testing. So still a little ways out. Baidu is one that's it's a regional one. It's kind of using more of those geostationary satellites. That is one run by China, so it's a Chinese-based system. They're also developing their own global one that will basically, surround the whole Earth, just like us and GLONASS. That one's called Compass. It's still not available yet. A few other ones to note that may be coming around. India is working on one, Ernest, and once again, kind of like the Beidou, it's going to be a regional based one, as well as Japan. Japanese have a system QZSS. Don't ask me what that stands for, but once again, it's a regional one. And there's numerous other countries that are also looking at developing their own regional based GPS global navigation systems. So see a lot out there. We're going to see a lot more coming into play. As you can see by the map there, the map kind of shows you the differences of where they are altitude wise. Once again, a lot of them are in that same 11,000, 12,000 nautical miles up there. Um, so yeah, it's something we're going to see a lot more of. GPS is one of those vital things going forward. So that concludes this unit. Hope you learned a little bit about GPS. Some of the activities that go along with this unit are kind of reinforce how do you operate that GPS, how do you connect it, how do we understand latitude and longitude, and everything that goes with that. So with that, that ends the video lecture for this unit. Have a nice day.